Hello, well, what we are going to talk about today is engineered wood products. So, when we talk about engineered wood, you're going to hear this term a lot now. A substantial amount of new home construction, specifically residential, not so much commercial because commercial is more along the lines of steel and concrete, but mainly residential, is going to use a substantial amount of engineered lumber in the houses. A friend of mine who does Flannery Homes, Bill Gursky, he estimates he uses anywhere between 70 to 80% of engineered lumber as opposed to solid dimensional lumber in his homes. And that percentage will vary because a lot of people will use it for their framing studs, their structural headers, things like that. But we're going to get into that, and I'm going to show you all the different types of engineered products there are out there. So let's take a look at the definition of what engineered wood really is. It's basically a byproduct of wood. It's made from wood products, and what they do, they either chip it, strand it, rip it into fibers or veneers, and then they glue it together. They laminate it, typically with an adhesive and typically with pressure also. So picture a gigantic press. They put this stuff together, compress it. A lot of times it's actually done under heat and pressure. And what that gives you is a very, very high density, strong engineered wood product. Now, why the heck do we use these things? Why not just stick with solid lumber? Well, I'll tell you, engineered lumber is really nice. It's a great slide in terms of really giving a quick rundown of this. Consistent in dimensions. In other words, it doesn't vary much. When you order a particular size, it comes out at that size. That is very much unlike dimensional lumber. Our 2x4s, 2x6s, 2x8s, they vary tremendously, believe it or not. They also are not very straight. They cup, they warp, they bow, they move all kinds, everything. They tend to shrink a lot on us. Dimensional lumber has very little shrinking, very little crowning is basically how it moves. It really doesn't shrink, it doesn't twist, cut, bend, crown, move. In other words, it doesn't deform. It's very stable. Now, under wet conditions, that's another story. Obviously, every product, specifically lumber product, will deform under moisture conditions. But again, engineered lumber tends to hold up exceptionally well just under typical environmental conditions. So with that said, it's structural components. Where are we going to start thinking about using these? Well, take a look at this. This is cool. Start in the upper left-hand corner. Here what you do, you're looking up at a subfloor being established. So here you have your beam, and then you have your floor joist running perpendicular to it, and then you have your OSB decking platform on it. So let's just take a quick look at these structures here. This looks to be a paralleled strand lumber, PSL. We'll get into these a little bit later. And basically, again, it is an engineered wood product. Parallel strand lumber just refers to the direction that this is put together in. Then you have your I-joists, your floor joists, and you guys have seen those in class, and I'm going to show you a whole lot more of those. And then you have your OSB, oriented strand board, and that is running perpendicular once again to your floor joists. So this is where you're going to see all your structural engineered components come in. Off to the right, what you have here is a header. And look at this, the wall studs are actually made out of OSB. In other words, engineered lumber. Now, down here is a variety of structural components I just wanted to talk to you about and how they're made. Let's start over here. These two should look pretty familiar. These are the glue lambs. Remember when we glued our little sticks up in class and stressed them? That really would be considered engineered lumber. We took solid dimensional lumber. You can see this is solid dimensional lumber, glued it together and made a strong member. Then on over here you have, let's see, this looks like an LVL, laminated veneer lumber. What this is slices, big slices, all these different layers glued together. And the same thing holds true here. A bunch of slices and layers glued together to make it incredibly strong. And then as we move on down into these components, these are our I-joists. As you can see, you have laminated veneer lumber here, and this is called the web, and these are called the cords. In the web, you have OSB in here. And here we have just a different dimension of laminated lumber. So all of these products here are considered engineered lumber. Everything there is engineered lumber. It's a byproduct of wood. This just happens to be laminated wood 2x4s. This looks like laminated wood 2x6s. Cool. Where else are we going to see it? Yikes, we see it all over in our subfloors. So this is OSB is what you guys are looking at, and again, I'll go in a little more depth on that. It's called tongue and groove. On a tongue and groove kind of fashion here, the tongue fits into the groove and prevents shifting of floors. On over here, this is your decking, your subfloor already complete, and these lines here are represented right here. So underneath of those lines, you have a tongue and groove scenario very similar to flooring to prevent these from buckling, cupping, warping, moving. So it's a very stable system. Here, what we're showing you is the sheathing of the house is made out of engineered lumber. The exterior of it basically is all out of engineered lumber. And this is just a good graphic, a pictorial of where you might have engineered lumber, and it could be the entire house. They make 2x4s, 2x6s, 2x8s out of engineered lumber. So this is not dimensional lumber. This is engineered. And when I say dimensional, that refers to solid hardwood or softwoods, and typically softwoods when we speak dimensional lumber. Cool, let's get into some different specific types. This is called plywood engineered lumber. And the reason it's called plywood because it's made in plies. This is 3-ply, this is 7, this is a 9-ply. When I'm talking plies, if you look in closely right here, you can see all the individual slices and they're glued together. Incredibly strong, okay? This can make incredibly strong. Fantastic. It's also fairly expensive too. So it is something to consider. It's very strong. It's not always straight. Sometimes it is not as stable as you'd like to believe it is. If we're looking for stability, I'm going to talk to you about that in another piece as far as flat and straight. But this is great for exterior and interior applications as well as finished applications. When I'm talking finished, you can see here it has a really nice layer of very nice wood on the top and then cores that are hidden below. It's a piece of furniture made out of it. Bicycle. I looked at that website. Pretty cool. They make actual bikes out of plywood. And this is a house being sheathed with plywood. Again, it's very strong, very stable. Most of the times it's fairly straight, but not absolutely straight. It tends to bow a little bit. What you're seeing here is plywood with a hardwood veneer on the top. In other words, it's all the plies like this, except it has a very decorative veneer on the top. Now, why do we do that? It's very cost effective. This looks to be a birch veneer on top. I really don't remember. This is a birch veneer, I believe, on top. It's a very attractive looking wood. In other words, this is a 4-by-8-foot sheet. That's 32 square feet of lumber. You can get something like this for $60 to $90. If you had to buy that out of solid dimensional lumber, that would be probably 4 to 8 times the cost of it if it was solid. So cost effective and strong. Here it's inlaid in a table, a very decorative piece. Here used as the back, actually the back of the shelves of a bookcase. It looks like real hardwood, but actually it's plywood covered with hardwood. That's one big advantage of plywoods and sheet goods in themselves. So let's move on. OSB, what I promised you. Okay, this stuff is all over the place. You've seen it down here, lower left, siding, sheathing of houses. You've seen it over here. It's another example of a close-up of sheathing of houses. It actually ties all your framing materials together, supports the house from racking and moving. Comes in 4x8s, 4x9s, 4x10s. It comes in a variety of sizes. This is just a 4x8 laying down, and this is a close-up of oriented strand board. Basically, it's larger chips or strands actually of lumber, and this is where they do use heat, pressure, and adhesive to make this material. Great stuff, moderately inexpensive. When I say moderately, I'm talking about $14 to $18 for a 4x8 sheet. That's 11, let's see, that's 7/16 thick. Now, there you go, 4x8 sheets. 4x9s. Now, they come in different variant thicknesses. You can get 7/16, you can get 5/8, 3/4, so on. So it just depends on the application as to where you're going to put it. So cost, I just spoke a little bit about it. It depends on the quality and size. So if I'm going to do something like this, and I'm going to use a real high grade veneer on my plywood, it's going to run you, $90, maybe even $120 to $160 per sheet. However, if I'm going to do something like this, low grade, that's going to be covered up, like I said, $14, $18, $20 a sheet. So it depends on the quality and, of course, the size. What sizes do they come in? Just went through that, but also I wanted to make you aware there's other sizes. There's these goofy sizes. This stuff called Baltic birch comes in a 3x5 size. It's actually used often in cabinet construction for building cabinets. So it's really good material for cabinets. It's straight and it's solid. Now, speaking of solid, we also have these things called chipboards, which is made basically, once again, heat pressure and adhesives, ground up wood product, pressed together. A little more porous, not quite as strong, not nearly as strong as plywood. This was a cool one. I've worked with this. It's actually wheat board. It's a byproduct of wheat. And it's cool. It smells, when you cut it, it smells like you're in a bakery. It smells good. Hasn't caught on in great popularity. I've only used it in a couple homes that were really built for a sustainable feature, and the people definitely wanted a low VOC, volatile organic compound, and very, very sustainable. What would they refer to that? I can't think of it off the top of my head, but basically something that's non-allergenic, basically a very neutral material, and the wheat board was really good for that. The other one we have, and I'm going to show you in class, MDF, medium density fiberboard. It's very dense, paints up really well, it's really straight, really weighs a lot, not really attractive. However, you could put a layer on that of hardwood and make it attractive. Now, let's speak a little bit to engineered flooring. So, flooring even is engineered. If you guys take a look down here, we have the difference. Solid flooring as opposed to engineered. Solid is one thick piece of dimensional lumber, engineered multiple layers. And again, this enjoys the benefits of all the engineered lumber that I showed you at the beginning. It's straight, it's flat, it doesn't warp, so on and so forth. It's actually made of layers of solid wood. So it's light layers of solid wood glued together, and it's strong, it's durable, great stuff. This is what it looks like in cross section. In other words, if I took a piece and sliced it, I talked to you a little bit earlier about the tongue and groove scenario. This is so it couples together well, mitigates the movement of it, also locks it in nice and tight. So again, this is just a couple examples of solid lumber versus an engineered kind of multi-layer lumber. Very similar in terms of how they're installed, but different, obviously, in terms of their composition. So that is a run-through of engineered lumber. When we get back into class, I will bring out a tremendous amount of examples of it because it's something you do need to know and understand, and have a great appreciation for the big share of the market it holds in our residential construction. So that's it for engineered. I will see you in class. Bye-bye.